Yeah, I guess it's like a
I like the orange and yellow.
mixture of these other stuff. But
This is just
acoustics
so
are
cool.
really good. Alright. I like the way it is.
Very nice.
my student also has one, he's an older one. And on the one hand, people complain about service a little bit, but on the other hand, it's never had any issues, so far.
Okay.
And it does have kind of flaky, like, materials some places, but mine's fine, but like my students have these chips off of it everywhere,
Oh,
you know?
really?
But it has no functional
Right, okay.
significance, so it seems to be fine.
Came in the market for your laptop.
Yeah.
And the last time I bought a laptop was for my freshman year of college.
Oh,
so
things have changed a lot.
Things have changed, and you know, there's like a lot more the user interface for things are much more competitive with Apple, and
Yeah.
I'm a little hesitant to just buy another Apple because they're only really good for the shelf life of these things and stuff.
Yeah, I do notice, you know, my husband's a Mac person, I'm a PC person. I used to have Macs, I mean, I've had everything.
Yeah, I mean, our
And-
whole,
Yeah.
my husband has Macs. But,
Yeah, but my computers do last longer than his, that is true, you know, and.
I mean, my, you know, so
A lot of
it was-
times they were just lighter, the PCs were lighter, that's why I
Right.
switched, you know, the Macs were so heavy for so long.
I don't care for work, but my old one, you know, it's 2007, it's almost
Yeah.
10 years old, it still functions.
Yeah, that's good.
The battery doesn't really like to stay charged, but,
Yeah.
and it's, you know, 4 or 5 operating systems old and therefore a little more
Right.
vulnerable and,
Yeah.
but I don't.
And plus after a while, it's probably gotten so defragmented and so all these other
Oh,
little
yeah.
things, right, I mean.
But, you know, and I don't really do computing, so
Yeah.
I don't really have the need
Yeah.
for the processing power that others would.
Right.
But I need Word to work.
Yeah.
And the internet and my email, and,
Yeah.
you know, most of
Yeah.
that is accomplished on a tablet these days, so,
Right.
you know, what can I get that's
Yes.
useful that's not maybe
Well,
$1,200?
Right, and the good thing these days, you know, too, is that they, a lot of them, they start up really fast and even, you know, they save a lot of state, so even sometimes when they crash, you don't even realize they crashed, because they just came back to exactly the same state. And so they're really they're very cool. You'll find you like it, I think.
Okay.
I was gonna say, I know you
Have
have
a
to talk to one
meeting.
person.
Whenever you have a meeting, I know you're not thrilled about having another weekly meeting, but. There we go. Yes.
I see no anomalous chocolate.
I guess the classes here start 5 minutes
Yeah,
after
so
they're
you're-
advertised.
Yeah.
And I so late. It was like 4:02. Because I actually had a professor who would,
I was trying to
if I
fix it
quiz or
yesterday.
something, he would lock the door to the classroom, so the only way to get into the classroom was from across the stage.
Right.
And, if you weren't there when the class started, you weren't taking that quiz.
Oh, yeah, yeah.
And it was like the sources, so like
Yeah.
3 other people were like,
Exactly.
I have to try on my bridesmaid dress today.
hello.
You got something?
I think we should have it running.
Leslie and I, we was live.
Well, people spend an awful lot of money on something that has no
Right.
value past one day.
I know. I have to spend money too. I have to buy the dress. I have to go out to downtown Boston.
I said it earlier, I only heard from one person.
That sounds like a thing that makes little sense.
My entire, like all the rest of the album.
And I only have, they told me I have to be out in half an hour. Which is.
Who was the boss? Who said this?
Exactly.
So
But
I-
then there's the questions and.
So I'm going to whatever place my friend is designated as the place to buy the bridesmaid's dress. And everyone in her bridal party has to wear a different dress, so there are limitations on dresses I can try on. And it has to be bought.
If someone used to just.
I don't have to.
Some things we made during a different school that it's all about.
Here's this.
Yeah.
That it was impossible to start
Things
those
that
on
change.
like,
You've seen this.
that was a thing.
Are these, oh, these, well, these seem to be really
Who said 1155, people would say, oh, those digits sound like they're significant, I gotta really start.
So for example, if you, how would you, if this looks like it's a sensor, is it the steering is a certain angle? How's that work?
Dave here has actually been sending signals to these
I don't know. Ultimately, that's your decision.
Good. So this is all this is sensor points.
Yeah.
None of these are effects.
Because okay, so
And you can't like ask questions.
It's baked in your DNA.
so first of all, the distinction between path and trajectory tracks is something that so a lot of people talk about in cars in particular. First order knowledge.
It
So
wasn't,
what I
but
understand is,
is it
And they talk about
you know, there's nothing here that says.
trajectory defined in position,
There's nothing here that says.
and they just talk about
says
regulating
whether something is
path
outgoing or
tracking, which means first order response to a position, whereas trajectory has
Man,
a
where'd you get
trajectory
this?
defined.
not working towards spreadsheet? I can find out.
So, I mean, we often don't want to use it for specifying, we can say that positions are defined, also the plot out. Of course, you could take by different positions are defined, because that's, stabilizing to that. That's the only, I think it's just a, sort of syntactic,
And there was another paper, it was actually published in 2009, that used their word.
there's nothing like,
Oh,
there's no depth.
So there was
Just-
Oh.
just saying that some people say fast track, so
What we're trying to do is actually
people saying fast tracking are often used for first order models.
for sure that was.
I want to know what things we don't understand.
Yeah, so I wouldn't.
We have to see.
Dynamics in the path tracking are sometimes very simple.
This is wrong.
Okay, so the second thing is, okay, what feedback could avoid
You don't have
obstacles?
this,
Could you,
I don't know if the laws make sense at all.
could you
Because I don't
get to
know
a
what makes
goal?
sense.
So I
I
think
want
the,
sensor output, I'm not assuming controlling this.
you need some estimate of where you are relative to the goal, of course, but it doesn't have to be
Well, I'm not sure I can
full
like this.
state, right? So it could be just in direction to the goal, and in general, this whole output
It's too
would
much
actually, another word that a set of words I would like to use for it would be task relative to status definition.
And it outputs
Oh, so it's,
so much data, it outputs all, I can actually show you a picture.
So what's it out?
Everything you're thinking about falling
so
within
it's-
relative related task relative to status definition. In some cases, you can accomplish a task with no status definition, that's meant,
Because it's meant for,
and you need some state information, that's better, but oftentimes you don't get some.
customized,
Right.
Toyota technician.
And it's too much to ask, and it's actually sort of wrong to get an estimation, because you might be wasting resources to estimate.
This
the
is what it
output.
literally is.
Yeah.
Flying in.
You want to be a semi.
So you can turn the screen back.
Oh,
And these are also.
am I supposed to?
Well, then that's not the.
Yeah.
I don't think we need it. I'm happy to do it. I think we're good. Yeah, whatever you want to start with.
Okay.
Cool.
Alrighty, folks, there's a lot of people gone today, including Daniela, who usually stands up and makes noise so that everyone pays attention, so I'll just do it. Yes, and I feel a little bit like I have bad breath or something, so maybe you could sit a little closer.
No, the reason why is because sitting this distance gives us a good visual, you know, you
Yes,
have to.
yes, I know. It's like sitting in the front row of a movie theater, I know. Okay, so we have a multi-PI project, which we called Uncovering Pain Points in Driving. And here's the general picture is, the overall goal of the CSAIL Toyota Research Center, as we understand it, is instead of it developing a truly automated vehicle, is instead to do a semi-automated vehicle that will just step in and complement the driver in times when the driver could use it. And so it seems to us that an important question there is, if you're going to step in for the important stuff, for the dangerous driving situations, for the difficult driving situations, then what are those situations? And so our overall goal is to study the human through a combination of both directly studying the human and some computer vision and data mining, to try and figure out what those situations are. And those situations, that there are multiple components there. Some tasks or combinations of tasks might simply be difficult or dangerous. Some environmental factors might make a task difficult or dangerous. And also, it'd be useful to know what the cues are that the driver is in trouble and struggling. And so we're interested in trying to get at all of those different aspects of this.
So let's start with just like what driving tasks are difficult or dangerous. And I think you might be surprised at how little is known about this. And what is known is maybe even a little bit conflicting. So on the one hand, from the driving literature, if you asked people to give you a list, I think you'd get a pretty coarse list of things that are bad. Distraction, whatever that means, you know, being tired, having been drinking, you know, bad weather is bad, and there's like these other kind of things like, you know, it's easier to turn right than it is to turn left and stuff like that. But so I think we'd like to at least attempt to try and get a finer grained estimate of what things are dangerous and or difficult. Now, on the other hand, from the human perception / cognition literature, you would probably get the conclusion that virtually all multitasking is bad. But I think we have to really call that conclusion into question. Because, you know, if you think about what driving involves, right, you're constantly, you're monitoring the person in front of you for whether they're slowing down, and you're staying in your lane, and you're checking for signs that will tell you where to go, and you're making sure pedestrians aren't stepping in front of you, and you know, you're controlling the steering wheel, you're controlling the gas, and you're controlling the brake. I mean, pretty much all driving is multitasking, and so if multitasking was really that bad, it's not clear that you could drive. Driving itself would be much, much worse than it is. So I think we have to get a new view on what's really involved in doing multiple tasks. And some of what I think has gone wrong, if you will, from the human perception literature is a combination of, they've often studied very artificial displays and tasks, and it's not clear how well you could generalize to the more natural displays and tasks. And also, I'm going to argue a little bit, there's probably confounds in the experiments people have run that have led to this conclusion. So some of what we'd like to do is get in this gap, try to get some finer discrimination of what kinds of things are difficult or dangerous, try to get sort of new, more realistic basic science on what tasks are difficult and hard, and so on. So there's two basic sort of prongs of the attack here. Yeah.
So, I mean, maybe could I group those categories into, like, there was the environment being hard, there's some intersections that are just really bad.
Right.
And then there's sort of the state of the world, which would be like the other drivers and the weather and stuff like that.
Right.
And then there's the state of the driver.
Right.
And is that a fair categorization?
Yes,
yeah?
I think that's a perfectly fair categorization.
And you're zooming in on the driver's side, I guess, right?
Well, except we also want to understand the environments also. I mean, I don't know if it was you or someone else was suggesting, you know, you could conceivably learn like actual intersections are bad, right?
Yeah.
Just based on data
Well,
in the world.
there are some roads that are regressive. And
Right,
others that are not.
right. Absolutely, I think that's a great idea, but we also kind of want to try to get just like from the driver's point of view, what does the scene look like, and can we make some judgments about whether that scene is going to be bad, just based on what the driver can see in terms of how many cars there are, and what the cars are doing, and what the roads look like, and what the road clutter looks like, and everything. Can we also kind of from first principles decide that this intersection is bad and not need the data necessarily? So. Okay, so we're going to do some just basic science of the human in the loop here, the driver. Mostly we're focusing on the perception and attention, which is what my lab specializes in, to a lesser extent, especially later years. Also thinking about more cognitive decision-making aspects of this, but in the short term, more like perception and attention. As you'll see, we're going to attack this with a combination of running behavioral experiments on humans, and also to a lesser extent, especially in the earlier years, modeling, but hoping to bring more modeling on board later on as well. And on the other side, we'd like to understand what's going on from applied driving studies. And it turns out that there's actually a fair amount of driving data out there. And the big thing that stops us from easily learning from that driving data is that, I mean, you'd like to do, say, data mining on that data, but the problem is an awful lot of it isn't labeled. And especially, as I'll mention, a lot of the video that people have taken isn't labeled. It's incredibly time-consuming to get a human to label it. And so we'd like to use some machine learning, computer vision style techniques to try and better label that data so that we can then do data mining on it to try and learn what are the difficult situations and how can we identify them. So here again, the point is just basically to facilitate, in the short term, just to facilitate the data analysis of the existing data that's out there. Now, of course, these two sides should inform each other and they should ultimately agree, right? The basic science that we do could suggest some of what to look for in the data that exists. Whatever patterns we find in the data could suggest what experiments to run on the humans. Hopefully, ultimately, if we've got our basic science right and if we've analyzed enough data, those two should agree about what things are dangerous and difficult, right?
But do you actually have data that contains the stuff you want? I mean, like, do you have data of the drivers while they're
Absolutely.
Yeah, you do.
Yeah. And I'll say a little bit more about that
awesome,
later.
yeah.
Okay, so let's talk about the basic science side of this first. Looking at perceptual and attentional factors in multitasking. Mostly the behavioral side kind of focuses on what I'm calling multitasking, but as I mentioned, since most of driving is really doing multiple tasks at once, you can just think of it as like driving, how difficult are driving tasks as that counting. It doesn't necessarily mean like I'm fiddling with my radio and I'm trying to drive. It's just driving difficulty in general. Okay, and as I mentioned, researchers from the basic science side of things have thought multitasking would just be disastrous. There's a lot of evidence it's not really that disastrous. And so, and for the next bunch of slides, I'm going to kind of delve into cognitive science, which is not our usual thing here, but tell you some of why I think people thought it would be disastrous and why there's hope that we can better understand it and maybe it's not so disastrous. There's a couple of phenomena which I think are the main sources of people thinking this would be so disastrous. One of them is visual search. So here, for instance, you're going to look for an O, and you're going to clap your hands when you see the O. Okay, is everybody ready? Yeah, okay, ready? Okay, so sometimes search is easy. That's not such a big deal in many ways. The interesting thing is sometimes search is considerably more difficult. Here you're looking for an orange square. Ready to clap? Okay.
No, there is not.
As you can see, it's more variable, it takes longer, it's more difficult, right? And this has been known for decades and decades, but I think it's important to sort of tease apart, like, why is this interesting? And it's interesting that you get difficult search because if you look at an individual item in that display, it's easy to tell those items apart, right? It's easy to tell an orange square from either of the other alternatives, the blue square or the orange triangle, right? And so what I'd like to suggest is how to think about this is that this is evidence that vision must not be the same everywhere. In some way, vision can't be equally faithful across the visual field. Okay, because if it were, the fact that it's easy when you look right at the item should mean it's just easy. Okay? And similarly, there's these great
There's just more things happening too. It's not just the location in my visual field. There's also there's more things happening here.
Yes, so, but I think in a different way than people have thought previously.
Okay.
And I don't have those kind of details in here, but we could talk more about it. So here here's a classic change detection experiment. You've got two different versions of the image are going up there. There's one change between the two. I put a gray, as is typical for these experiments, I put a gray field in between the two images so that to get rid of any image transient. So there's not like this motion cue to what's changing. And it can be hard to realize what's changing. Has everyone seen the change or not yet?
Yeah.
Okay. But like once you actually see that it's that box on the boat that's appearing and disappearing, then again it's pretty easy to see it. It's not like it was, you know, like an illusion or something. I mean, it's not like it was not visible, right? And so once again, this is like evidence that vision seems to not be the same everywhere. Now, the interesting thing here is, you know, is where people went with these what I'm calling the not the same everywhere phenomena. And there's these, but there's also other ones. You could think of impossible figures. Why is it so hard to tell that they're impossible? You know, Escher drawings. You could think of the old Ullmann style, or these two dots on the same line, kinds of cognitive puzzles. Those are also not the same everywhere phenomena. And fairly universally, the interpretation has been that the way in which the vision is not the same everywhere has to do with the differences between vision where you're attending and vision where you're not attending. And this is where it started to look like it spoke to multitasking, right? And so the idea is that you have much more information, much more faithful representation where you're paying attention than where you're not paying attention. And
that plus some somewhat simple models of what might be happening in vision have led people to conclude that without attention you can do very little. You get these very basic features, you can't combine them in any useful machine learning kind of way to make decisions, you can only like make some very basic decisions. Vision should really be bad without attention according to the conclusions people have come to here, okay? But a lot of what we've been doing in my group recently is suggesting that perhaps there was another, lower hanging fruit, if you will, in trying to understand these phenomena, that there might have been a more obvious way in which vision is not the same everywhere, which is that we have foveated visual systems. By which I mean that the vision at your fovea, which if you hold your arm out at arm's length, you hold your thumb out, your fovea is about the size of your thumbnail. That vision there is higher resolution and more faithful and all sorts of other things than vision in the rest of your visual field. And then maybe that is really the difference between, that's really the reason why vision is not the same everywhere. Now, that seems in many ways like the more straightforward explanation. And so you might ask, why do people go to attention as an explanation instead? And I think some of that is that the really, like the big fish in the difference between peripheral vision and foveal vision is this thing known as visual crowd. The effect you're seeing is perceptual and how much of it is attentional. We've done this actually for the gorilla case. You could also imagine in the driving case it might look something like this. Maybe I tell you, look at the GPS/radio down there, right? And then I can see to what extent you can notice that the brake lights come on, right? This is better on my screen than on yours, but at any rate,
The thing that gets me is this person walking behind.
Yeah.
That's the immediate thing that hits me.
Yeah. But at any rate, so the plan is to run a lot of these experiments in these driving situations. We are to some extent going to collect our own video for this, but we also to some extent will bootstrap on some existing driving video to try and do this. There's been a little teeny bit of this done in the driving literature.